My name is Muxavania Christian, and I'm doing the music recommendation system. So I'm the author, Makerere University. So the real life problem, until recently, music discovery was a challenging task. So what the AI doesn't basically, it recommends music to the user instead of browsing through a bunch of songs. So the AI in the music recommendation system provides the user with the music he wants basing on his moods and tastes. So the Spotify dataset. So I chose to use the Spotify dataset simply because it contains the data concerning artists, the genres of the music, the release dates of different music, uh, which is as like the recommendation system, like the whole point of the AI. Then the factors I considered for the dataset, uh, the genre, I had to choose a data set with different genres of music for the model. If the model is to recommend basing on the genre of the song the user is interested in, then the year of the release, since some people, you can find people interested in the music which was released in the 2000s, early 1900s. So that's why I had to select a data set with a year of release. Then the artist information, some users like music basing on the artist, just like music of a particular artist. So in this case, I had to choose a data set with artist information. This includes like the name, music, and biodata basically. So the important features of the Spotify dataset, this is the model algorithm. This contains the variables in the text of the dataset, and the model is created to read this algorithm. System requirements, like in this case, the user has to rate the music he listens to by a device he's using. Then training data, this is the data I'm going to use to create the music recommendation system. Then testing data. This data mainly determines the efficiency of the model. So Bayes theorem in statistics and probability theorem. The Bayes theorem is also known as the Bayes rule. It's a mathematical formula used to determine the conditional probability of events. So Bayes theorem describes the probability of an event based on prior knowledge of the conditions that might be relevant to the event. So that is the formula, as you can see down there. So this is the formula of Bayes theorem: probability of event A occurring given that event B has occurred, probability of event B occurring given event A has occurred, probability of A, and probability of B. Note that events A and B are independent events. Then we have naive Bayes. Naive Bayes is a supervised learning algorithm which is based on the Bayes theorem and used for solving classification problems, for example, text classification. So it is a probabilistic classifier, which means it predicts on the basis of the probability of an object. So it's used in building fast learning models that can make quick predictions like spam filtration, sentiment analysis, and classifying articles. So it's called Bayes because it depends on the principle of the Bayes theorem. Then it is called naive because it assumes the occurrence of a certain future is independent of the occurrence of other futures. So Bayesian networks. So a Bayesian network is a probabilistic graphical model which represents a set of variables and their conditional dependencies using a directed acyclic graph. It is probabilistic because these networks are built from probability distribution and also use probability theory for prediction and anomaly detection. So real-world applications include Can be used in various tasks, including prediction, anomaly detection, diagnostics, automated insights, and many others. So a Bayesian network consists of two parts: the directed acyclic graph and the table of conditional probabilities. So so a Bayesian network graph consists of nodes and arcs. Arcs can also be called directed links. Each node represents a random variable, whereas a random variable can either be discrete or continuous. So discrete we can discrete can either, okay, for example, someone's gender, like female or male. Then continuous, you can use an example of someone's age. Then these arcs or directed arrows represent the causal relationship between the random variables. So in this case, A, B, C, D are the variables, as you can see. Then you have the differences between Bayesian theorem and naive theorem. So with Bayesian theorem, it allows the user to specify which attributes should be independent. But with naive theorem, it just assumes conditional independence. You can see the formula. So with Bayesian theorem, okay, like the Bayesian network is made up of arcs and nodes. Whereas the naive theorem, it is an algorithm based on Bayes' theorem used for classification problems. So whereas Bayesian theorem is used for building models for data and expert opinions, naive theorem is used for models like spam filtration, sentiment analysis, and classifying articles. So we have the difference. Okay, good. The continuation. It states Bayesian theorem states the relationship between joint distributions and conditional distributions. Whereas naive theorem, it is simplification. It's a simplification of Bayesian theorem by assuming that y is conditionally independent of the sample space given x. This one is below the references. Thank you for listening.